Okay, so what you're looking at right now in Chapter 9 is all going to revolve around working with roots, or these are often referred to as radicals. So in Section 9.1, I think that section's pretty straightforward. Looked like you didn't have any trouble with that. Just kind of some basic evaluating square roots and cube roots. So what I want to focus on with you here in this video is Section 9.2. All right, so in Section 9.2, you're looking at simplifying radical expressions. That means you're going to be looking at situations where you're asked to take a square root, but what's underneath the radical is not a perfect square. Or the same thing with a cube root, but what's underneath the radical is not a perfect cube. And so what you end up having to do is break it down into smaller chunks. So the process for doing this, I gave you kind of 3 different approaches here. And remember, these notes are all posted for you under the Course Materials tab. So you can find blank notes that you can fill in, and then you can use my completed notes there as a guide, which is going to be exactly what you see here. But the approach that I would suggest you use is either approach A or approach B. Approach B is going to be the quickest. And what you do with that is you look at what's underneath the radical and you take the largest factor that you would be able to take the square root or the cube root of. And then you use that to break it down and simplify. And so like here in this example, the square root of 200, 200 is not a perfect square, but I started looking for factors that were perfect squares and I went as high as I could. So the biggest factor of 200 that is a perfect square is 100. And when I do that and write this as 100 times 2, then I can break this up into 2 separate radicals. And when I do that, I'm able to take the square root of 100, pull this 10 out of the radical. When you take the square root, it comes out in front of the radical. And then I have to leave the 2 underneath the radical because that cannot be broken down any further. And again, what this is called is simplifying the radical. Now, approach 1, what's shown here in part A, a lot of times this is what will happen even if you're trying to use approach 2. So what happens in approach 1 is I just started looking for factors that were perfect squares. And the first one I came to was 4. Right? 4 is a perfect square, and 4 is a factor of 200. But notice what happens if I do that. Then I end up with the square root of 50, which can be broken down further. So it just means I'm not finished yet because I didn't take the biggest perfect square. But all that means is that I keep going. So I look at 50, and I start thinking about factors of 50 that are a perfect square. All right, and the biggest one is 25. And then I broke that down, and notice it leads me to the same place. I still ended up with a 10 out in front and the 2 left underneath the radical. Okay, so that is the process that you're going to be using here in section 9.2. Now, I also want you to remember how you should be approaching each section. You should always start with the learn in Hawks. Right? Even before you go to my notes, start with the learn in Hawks. This is going to walk you through the basic concepts that you're going to be using. It's going to give you any properties that you're going to need. It will also show you examples that contain videos, which is good to see it actually being worked out step by step. And after you have done that, then I would suggest that you go to the course materials and you look at my completed notes so that you can see additional examples of things being worked out using the same properties that were used in the Learn section. All right, and then again, once you've done that, once you've kind of taken in all the information, then you know your next step is to go to the practice assignment. So I just want to work through a few examples here with you in practice, just again to kind of show you what the process is that you're going to be using here. So let's start. We'll start with this cube root. All right, so I'm asked to find the cube root of 100 or negative 128. So what I'm going to do is I'm going to start thinking about possible factors of 128 that would be a perfect cube, right, where I could take the cube root. And what I do, if I can't see it right off the bat, I just pull out my calculator, right? I take 128 and I start trying possible cubes, right? For example, if I take 128 and I try to divide it by the first cube that I can come to, which is 8, then that tells me that I can break this up into negative 8 times 16. All right? And that was okay. There's nothing wrong with that. But the big thing to remember is it's going to be quicker for you if you can make sure that you have the biggest possible factor that is a perfect cube. So before I keep going, I'm going to try some larger values to see if any of those work. So for example, 128, the next possible cube, 2 cubed is 8, I tried that, 3 cubed is 27. So if I try to divide 27, that doesn't work. It gives me a 4.74. So I'm going to take that 128 and I'm going to try the next perfect cube, which is 64. And that works as well. Right? So because I was able to get something bigger than 8, I'm going to go with the larger factor of 64, actually negative 64. And then that's going to leave me with just 2. Negative 64 times 2 is negative 128. And then what I'm going to do is break this up. This is the cube root of negative 64 times the cube root of 2. We're just breaking up that product. And remember, you can take the cube root of a negative number. You can't take the cube root, or you can't take the square root of a negative number, but you can take the cube root. So negative 4 to the third power would give me negative 64. And then I'm not able to break this down any further, so the 2 has to stay underneath that cube root. Now, the other thing I want to mention to you is be careful when you're putting your answers in. Make sure that you're using the math palette correctly. So when I type my answer in here, I'm going to put in my negative 4, but then I'm going to bring up the keypad. And I want to make sure that I use the correct root here. So when I bring up, whoops, let me go back here. When I bring up the square root, right, the general radical, if it's anything other than the square root, I need to make sure that I include the root right there. So notice what I did. I tabbed back, or I just clicked right where that little root number would be, and I entered the 3, because if I don't put anything in there, it will assume it is a square root, and that's not what we have here. So remember, what we're looking at here is negative 4 times the cube root, and what's underneath that radical is 2, and then I submit my answer. Okay, so just be real careful about how you input that information. If it's not a square root, make sure you put the root right there in the little V of that radical symbol. All right, now you're also going to come across ones that contain variables. All right, so let's look at one more here where we have a variable that needs to be included. So let's take this one right here. So we're asked to simplify the square root of 18x squared y squared. Now, when you have multiple factors underneath the square root, things that are being multiplied, you know right off the bat you can break them up. So I can rewrite this as the square root of 18 times the square root of x squared times the square root of y squared. All right, you can't break it up if it's got a plus or a minus under there, but if it's multiplied like these are, then you can. So what that allows me to do is start with just the numerical value that's underneath the radical, And again, 18 is not a perfect square, so I can't just take the square root. But it has a factor of 9 that is a perfect square. So I'm going to write the square root of 18 as the square root of 9 times 2. And then remember, what I can take the square root of, right, the square root of 9 here is 3. That comes out in front of the radical. We've taken the square root of it. And what remains underneath the radical is just the 2. All right, then I'm going to come back up here and look at the other 2 factors that need to be included. When you have an exponent and you want to take the root, right, whatever root you're taking, you can determine what it's going to do to that power if you take the exponent and you divide by the root. So what I would do in this case is I would take the x squared, but because I want to take the square root, I'm going to divide it by the root of 2. And notice in this case what's going to happen, that's going to be x to the first power, which is just going to leave me with x. And the same thing will happen over here. I've got y squared. I'm going to divide that exponent by 2 because this is the second root. That's going to leave me with y to the first power, or just y. Now, you can enter it just like this in Hawks, and it will be perfectly fine, but you've got to make sure that you don't mistakenly put these things underneath the square root. So what I like to do is when I finish, anything that no longer is underneath the radical, anything that I was able to take the square root of, I like to pull all that out in front, so there's no chance that it accidentally gets stuck up underneath that radical. And then everything that gets left under the radical, I leave that here on the end. All right, so when I input my information here, I would enter the 3xy, and then I'm going to bring up the radical. I don't have to put a 2 in there because it will assume that it is the square root. Wouldn't be wrong if you did. And then what we're left with underneath that square root is a 2 as well. All right, I want to look at one more here with you. See if I can find one. Let's see. Let me go back. That's not quite showing me what I want to look at here. Let's look at this one. Sometimes you'll have an exponent where it's not able to divide by that root. It would lead you to something that's not a whole number. And that's what we're looking at here. All right, so in this example, I want to take the cube root of 192 x to the 8th power. Now again, the first thing I'm going to do is I'm going to break this up into individual factors because there's a multiplication in here. I can do that. And I'm going to write this as the cube root of 192 times the cube root of x to the 8th power, much like we saw in our previous example. All right, then I'm going to look at 192. The first thing I'm going to do is just see, is it a perfect cube? Can I take the cube root? And when I do that, I see that I can. It comes out 5.76 and so on. So I'm going to start looking for factors of 192 that are perfect cubes. I'm going to start with 8. Now that works. 8 times 24, but I'm going to see if I can go any higher. All right, I'm going to take 192, try 27. That does not work. 192, the next possible perfect cube would be 64, and that one is going to give me the biggest possibility. So I'm going to write 192 as 64 times 3. And then we know whatever we're able to take the root of, right, the cube root of 64 is 4. That's going to come out in front. And what I'm going to be left with underneath that cube root is a 3. All right, so I took care of the numerical part. Now I'm going to come over here and look at my variable. Now, normally what I would do is I would take the exponent and I would divide by the root. But that's not going to work for me here because 8 is not divisible by 3. And I don't want to end up with a fraction or a decimal for the exponent. So what I'm going to do here, because I just want to simplify, is I'm going to rewrite x to the 8th with the highest possible exponent, not passing 8, that would be divisible by 3. All right, so there's 3, that's divisible by 3. There's 6, that's divisible by 3. There's 9, that's gone too high. All right, you can't pass the exponent. So that means 6 is as high as I can go without passing 8 and have something that is divisible by 3. Now, if I write x to the 8th power in terms of x to the 6th power, then I got to write this as a product, just like my 64 times 3, x to the 6th times x to the 2nd, there would be 2 more left, would give me x to the 8th power. Notice I'm not changing what's under that radical. I have to make sure I'm not changing it. I'm just writing it in a different format. And then notice what I can do here, right? I can divide an exponent of 6 by 3, so I'm going to do that, right? I'm going to take the cube root of x to the 6th power, just taking the exponent and dividing by the root of 3. That's going to come out of the radical because I'm taking the cube root of it and bringing x squared in front. And then the x squared, I can't do anything with that. I can't divide by 3, 2 over 3. That wouldn't simplify. And I also can't rewrite 2 in terms of anything that is divisible by 3 because it's smaller than the root. So when the exponent that you have underneath the radical is smaller than the root, you can't go any further, which means I'm going to leave the rest underneath the cube root, which is x squared. And again, what I like to do when I finish is bring everything that came out of the radical out in front. That's going to be the 4 and the x squared. And then everything that stays under the radical, I put at the end, which is going to be the 3 and the x squared. Now again, be really careful about how you input your answer here because you've got an exponent, you've got a root, and then you've got another exponent underneath that radical, right? So you just want to make sure that you input everything correctly. So what I would do here is I would put in my 4x squared first. So I'm going to hit my exponent button there to do x squared. Then I'm going to come back down out of the exponent. That's important. And I'm going to bring up my radical. Now this was a cube root, so I'm going to hit the radical button, but then I'm going to go right there in the V of that radical and make sure I specify it is the cube root. And what's left underneath that radical is a 3x squared. And notice all of that stays underneath that radical, the 3 and the x to the 2nd power. And when I submit, then I have simplified completely. All right, so if there was anything in particular in this section that was giving you trouble, hopefully either by following one of the examples that I just worked through with you or by looking at all the examples, there's a wealth of examples for you in the completed notes. Hopefully that will take care of any questions that you have. If not, make sure to let me know so that you can get section 9.2 certified by the due date.